Hi everyone, my name is Clive and I'm the co-founder and CEO of a company called the Rockflower Company, and I'm here to tell you today about the immense power of small rocks. It's going to get a bit sciencey, buckle up, it's going to be fun as well. 250 million years ago, a series of massive volcanic eruptions caused a massive spike in the concentration of atmospheric CO2, which consequently raised temperatures by 10 degrees in a very short space of time. This was called the Permian-Triassic extinction, and there were 90% of species that were extinct in this particular event. Scientists refer to this as the Great Dying. When we look at atmospheric CO2 levels in the past, we clearly see this peak of CO2 in 250 million years ago. We also see that we're dangerously heading towards a similar peak, which could cause another Great Dying event. So that's the bad news when we look at CO2 levels over time. But there's some good news in this chart, and that is that CO2 levels naturally come down from these sorts of spikes. Nature has a way of doing that. When the system is taken out of equilibrium, there are natural stabilizers that bring CO2 back out of the atmosphere. The question is, though, what carbon reservoirs has nature used to reduce CO2 from the atmosphere and bringing them down from these prehistoric peaks that have happened in the past? I'll give you three candidates. There's plants, oceans, and rocks. So let's have a show of hands. Who's in camp plants? Who's in camp oceans? And who's in camp rocks? Well, the answer is all three play a role, but by far the rock star in terms of natural carbon capture is rocks. A stunning 99% of carbon in the Earth's crust, or the Earth's surface, sits in carbonate rock, sedimentary carbonate rocks, which is quite astounding when you think about it. So this is where it gets a bit sciencey, but geologists have well known this science for a number of years. It's called the long-term carbon cycle, and that's how rocks effectively take high levels of CO2 out of the atmosphere. So what happens is you get CO2 dissolved in rainwater, forms a weak carbonic acid. When that weak carbonic acid interacts with silicate rocks, it interacts with certain elements within silicate rocks, namely calcium and magnesium, to form a very stable bicarbonate species. That stable bicarbonate is transported efficiently in water systems to the ocean, where it sits in the ocean and eventually becomes carbonate rock at the bottom of the ocean. So that's a lot of science, but in essence, it's carbon dioxide interacting with one type of rock to eventually become a different kind of rock that's permanently sequestered at the bottom of the ocean. So this is what brought CO2 levels down in the past. So nature offers us some inspiration. But here's the idea. What if we could accelerate that natural phenomenon of silicate rock weathering that we know happens, it's very established science, to permanently remove atmospheric carbon and prevent what looks like we're heading towards is yet another Great Dying event? Turns out that's not my idea, and there's a number of fantastic folks, both in academia and in the world of entrepreneurship, who are taking this idea and running with it. Very recently, a very impactful Nature paper was written about the potential for what's called enhanced rock weathering to draw down permanently between 0.5 and 2 gigatons of CO2 from the atmosphere by 2050. Based on this, a number of startups have put themselves in this space and are developing this amazing technology of taking rocks and using rocks and this natural process of geology to capture CO2. And really, really excitingly, the X Prize was won by Mati Carbon, an Indian company focused on enhanced rock weathering, and they won a whopping $50 million for their particular approach to this technology. So the aim is fairly simple in a way, is accelerate this process from millennia to just a few years. The question is, how do we do that? So first, we've got to find the right rock. You've got to select the right rock, and it's got to be silicate rock. It's got to have enough calcium and magnesium in it to bind these dissolved carbon dioxide molecules. Then the key thing is you've got to enhance the reactivity. How do you do that? You take big rocks and you make them smaller, because when you do that, you increase their surface area for reaction. You increase how fast that natural process happens. So that's the key thing. You also need to move the rocks and put them in the right environment for that chemistry to happen as fast as possible. It turns out cropland is very good for this. Cropland is wet, cropland has the right pH, and cropland is typically in warm enough places to allow for this process to be accelerated. And then finally, and very importantly, and this is where the industry is focusing a lot of time, rightly so right now, is measuring and verifying that you've made an additional impact in an open system like a cropland. When you've moved rock from one place to the other, what is your net impact? How do you measure that? And how can you verify that? So the Rockflower Company is 2 years old. It's a startup on a mission to deploy the world's largest source of naturally pre-ground silicate rock for rapid carbon capture and other co-benefits. We were founded by the world-famous geologist from Greenland, Professor Monique Rosing, and 2 Degrees, a family office incubator and investor in Copenhagen. So what is the largest natural source of pre-ground rock? It's called rockflower, and it's glacial rockflower that's made uniquely in Greenland, so here in the Arctic. It's gigaton deposits that are created by the ice cap on Greenland of ultra fine rock particles. We're talking sub-10 microns. That's just infinitesimally small, which gives us this huge advantage of surface area to work with. It's very uniform in its composition because of how it gets created naturally by the ice cap. It's actually continually replenished. The ice cap on Greenland right now is grinding up rock for us and putting it nicely on the shorelines of Greenland for us to potentially use. And the key piece is those rocks don't react where they sit in the Arctic. It's too cold. It's not the right pH, and there's not enough interaction with atmospheric CO2 for that rock to be doing the wonderful chemistry we need it to be doing. So how it's made is the ice cap on Greenland, which is 3 times the size of California, and on average 3 kilometers thick, is day in, day out grinding the underlying bedrock in Greenland into very, very small particles. Then in the summer months, the natural meltwater transports those fine particles out of the glacial system to the shorelines of Greenland, where it interacts with salt water and precipitates out into these huge deposits of very fine ground rock. And as you can see in one of the pictures here, these deposits in Greenland are just massive. So what can it do, this rock? Well, we know silicate rock captures carbon. Well, how does this rock perform? So it can capture up to 250 kilograms of CO2 per ton, which is good. It's good enough for us to use. But really importantly, it does it faster than any other enhanced rock weathering feedstock on the market. And that was independently verified research done in Germany by the Carbon Drawdown Initiative. And you ask yourself why, and it's quite simple. It's the surface area advantage this fantastic material has. Sub-10 microns gives an over 400,000 square meter per cubic meter of surface area for this particular rock. That's 25 times more surface area than typical fines that you get from quarries or mines in the form of byproducts that are used by the market. So we see a huge, huge potential in just how fast this material can capture CO2. But on top of that, it also has these amazing agronomic benefits. It's a wonderful source of potassium that can replace potassium fertilizers used today. It also increases the efficiency of nitrogen, again, because of its small particle size and how that interacts with nitrogen. It improves soil quality over time, and it is absent of toxic heavy metals, which is also really, really important for using feedstocks for this purpose. So how it's moved: we dredge the material from where it sits in Greenland. We've checked in terms of environmental impact. There's no life form that we're disturbing in the deposits, and the deposits that we plan to take don't affect the nutrient supply to the surrounding ecosystem. We dewater the rock. That's all we have to do to it. There's no processing, no chemicals involved, using standard equipment. Then we transport it via bulk carrier. Bulk shipping is one of the most cost and carbon effective forms of transport to get this to global agricultural markets, where we then are able to spread the material just like any other enhanced rock weathering feedstock using standard farming equipment. Of course, we need to think about our logistics footprint, both in terms of cost and carbon. This material can't go to every corner of the earth and still be profitable and impactful. So we constrain ourselves in terms of where to take this to coastlines on the coastline of the Atlantic Ocean, where it makes sense to ship this material cost effectively and carbon effectively. So our LCA emissions are never more than 50 kilograms per ton, leaving us with a net carbon capture of 200 kilograms per ton of material to work with. And the magic $100 a ton number, we can meet that because of this unique material across farmlands that when we've done our bottom-up numbers, represents 40 million hectares of addressable market opportunity. At a $200 a ton price point, much more land is, of course, also enabled and unlocked by this. So where are we on our mission? We've secured 3 billion tons of this material under exclusive mining license. through deposits in southwest Greenland. We've proven the benefits in multiple field trials. We've mapped a pathway to profitability at scale. And now we're on a mission to get a first commercial pilot up and running of a small operation of 20,000 tons a year, followed by larger offtakes and much larger operations. So to leave you with 3 takeaways today, rocks are the key to solving the climate crisis. And if you haven't heard about enhanced rock weathering, you better get smart on it. And thirdly, just maybe, this stuff called glacial rock flour could become a global carbon negative commodity in our lifetime. Thank you.